Hi, I'm Surabhi Sinha and currently working as a machine learning engineer at Adobe, working in the domain of generative AI. So let's say I wanted to create a picture of a person exploring the Amazon forest, but I'm not that creative and it would have taken me hours to create something good. However, this is the picture I generated, and believe me, it took me less than 20 seconds to generate this picture using the prompt shown on the left. So that's the power generative AI has instilled in people. It has helped to democratize AI and technology to people like me and has truly expanded the horizons of creativity for all. So, what is generative AI? It is actually a technique that allows machines to generate original and creative content such as photos, music, text, etc. on their own. Gen AI's explosive boom has unfurled endless possibilities. From autonomous cars to virtual reality, the generative AI revolution is actually propelling humanity into an era of limitless creativity. From personalized marketing campaigns to product design optimization, generative AI empowers organizations to innovate and stay ahead in a rapidly evolving marketplace. And by the end of 2023, we expect over 400 million monthly active users for text-based Gen AI models. And for the use of image-based Gen AI models, it is predicted to experience a surge by 400x, and by 2028, these solutions will have penetrated over 90% of the smartphone market. So this truly tells us the extent to which Gen AI is going to impact businesses in the near future. But building generative AI models is a challenging task, especially in terms of resources and cost. The ChatGPT model that we all are aware of, it requires $700,000 daily to run. So this leads to various challenges for developers and companies such as scalability, user adoption, etc., etc. And not only this, but just imagine the carbon footprint these extreme ML models leave due to their excessive resource consumption. So this brings us to the need of making these models efficient. Otherwise, this won't be a long-term sustainable solution for us. So these generative AI models, especially those with high capacity and complexity, can have large sizes, requiring significant storage resources. So it's a need of the hour to make these models smaller, allowing them to be stored with lesser memory requirements. And not only this, Gen AI models with large sizes often lead to increased inference latency, causing delays in real-time applications. So balancing model size and computational efficiency becomes crucial to ensure prompt responses and smooth user experiences, particularly in real-time applications such as mobile apps. Moreover, let's say you want to deploy some models on resource-constrained devices such as mobile phones or IoT devices. More often than not, that you will face challenges due to limited computational power and memory constraints. Then optimizing model size and latency becomes essential to enable the efficient execution of generative AI models on such devices. And this will not only reduce the cost significantly, but will also reduce the model's carbon footprint. But now the main question arises, how do we actually make these optimizations? How can we make Gen AI more efficient? So there are various techniques for that, and a lot of research is being done on that as well. One such technique is knowledge distillation, where we train a smaller model known as the student to match the behavior and predictions of a larger, more sophisticated model known as the teacher. So let's look into it a bit more. Excuse me. So in knowledge distillation, the teacher model serves as a source of knowledge. It is typically a larger and more accurate model that has already been trained on a particular task or data set. The student model is a smaller and simpler model that aims to learn from the teacher's knowledge. And instead of using the hard labels, could be one-hot encoded targets, from the training data, knowledge distillation employs soft targets, which are actually the teacher model's predictions for each input. So the student model actually uses the teacher model's predictions to learn from, which is a more nuanced and informative way to train. We know that the goal of knowledge distillation is to compress the knowledge contained within the teacher model into the student model. But we also need to make sure that while making it more compact and efficient, we maintain a reasonable level of performance as well. So, yeah, moving on to the next slide, we have some more techniques that we can discuss for model optimization. So, another such method for optimizing models is model quantization. Quantization is a method that reduces the precision of numerical values that are used to represent weights and activations in a machine learning model. And by reducing the number of bits that are required to store and process these values, quantization actually reduces the model size as well as the memory footprint. So there are various types of quantization, but some frequently used ones could be. The first one is fixed point quantization. It reduces the precision of numerical values to a fixed number of bits, such as 8-bit or 16-bit, enabling efficient storage and computation while sacrificing some level of numerical accuracy. And then there is dynamic quantization. This dynamically adjusts the precision of numerical values during inference, allowing for a trade-off between model size and computational accuracy based on the specific needs of each layer or activation. Then we also have something called binary quantization, which represents weights and activations as binary values, rather than using floating point or fixed point representations, drastically reducing the memory footprint and computational requirements at the expense of fine-grained precision. So from the image, we can see that a higher precision will give us better accuracy, but will be computationally expensive as well. Whereas a lower precision model will be smaller and faster, but will compromise on the accuracy. So it's up to us and on our business needs on how we maintain a balance between size and accuracy trade-off. So we also have another model optimization method known as pruning, where we identify and remove redundant or less important weights, connections, or even entire neurons from a neural network. So this reduces the model size and computational requirements while maintaining performance. We have various types of pruning, such as weight pruning, which involves which involves identifying and removing individual weight values in the model that contribute less to the overall model performance. It can be based on magnitude, where we can prune weights below a certain threshold, or we prune entire channels or filters, which is known as structured pruning. And then there is neuron pruning. Neuron pruning basically focuses on removing entire neurons or activations in a neural network. Neurons with low importance or low impact on the model's output are identified pruned, effectively reducing the model size and computational complexity. And then finally, we have filter pruning. Filter pruning is mostly applied to CNNs, convolution neural networks. It involves pruning entire filters, which are also known as kernels, from convolution layers. Filters that have little impact on the model's output or are redundant get pruned, resulting in a more compact model. A typical pruning process involves identifying layers or neurons, or say weights that have a low impact on the model's performance. Then we prune or remove those based on one of the methods that we just discussed. Then we also need to fine-tune our model, again with the reduced set of parameters or weights, as we want to tackle any kind of performance loss that might have happened. And this is going to be an iterative process, and we'll repeat it until we are satisfied with the optimization needs and performance. So these were some of the model optimization techniques we can try. Effectively using these compression and optimization techniques can help us reduce the computational needs for the models, which helps in increasing the scalability of these solutions, along with enabling them to be deployed on resource-constrained devices. We can expect faster response times from these optimized models, which will improve the user experience drastically and increase adoption as well. Moreover, these efficient models would be cost-effective and would eventually lead to sustainable machine learning. Finally, I would like to conclude by saying that generative AI models need to be optimized in order to make them scalable and affordable. Making them smaller and faster would enable a plethora of real-time AI-powered applications that would not only be just low cost, but a future towards sustainable machine learning. And by the way, the picture of the tiger that you're seeing here is again generated by generative AI. And so thank you so much for your time, everyone. It was an honor to present today. And please let me know in case you have any questions.
Hey, hi, thank you, Surabhi, for your presentation. Can I ask the question quickly?
Yeah, sure, of course.
So you are in Adobe, right?
Yes.
So you are using, so Adobe also has come up with some integration of generative AI in their platforms. So which you can like talk about like what is the plans, like what are the open source models they are using, or are they using their own inbuilt models that are Adobe is developing?
So I think I cannot reveal like everything about what is happening behind the business. But yes, they are using a mix of some of the Gen AI models are actually open source, and they're forming multiple partnerships like with Microsoft, IBM, etc. But Adobe is also developing some in-house models as an intellectual property, if that answers your question.
Yeah, thank you. This wanted to, because and also one more thing regarding generate. I know about, I have tried for images. What text also, like Canva has introduced its AI, right? Like automatically, like Magic Designer. Is there any AI in Adobe for text? Like you can give ideas, like you want to do a presentation, and it is going to create a presentation according to your ideas or themes that are there.
Adobe, actually, I think it would be more suitable for Microsoft's business because they already own Microsoft PowerPoint. But Adobe has this text to image application. Have you heard about Adobe Firefly?
No, I have not heard about Firefly.
Okay.
I will
Okay.
try
So
it after the call.
okay, yeah, sure. Of course, I would love for you to try, and please provide me any feedback that you might have, because that's one of the products I'm working on. So Adobe Firefly is basically that text to image application, which is being developed and released. It has been recently released by Adobe. It garnered a lot of media attention and press. So yeah, please feel free to try and let me know, like, whatever feedback you have.
Thank you. Thank you for your answers.
Are there any more questions?
I think I see a question from Patrick. So I would just read it out loud so everybody knows the question. So he has asked that, so the teacher model teaches the knowledge to the student, but not transfers the underlying data and information. So that's actually true, Patrick, so yeah, that's actually true, Patrick, that student model actually learns from the teacher model because of the laws, because that's how the laws function and everything is designed in knowledge distillation, but it does not transfer the exact underlying data. So you can protect your data if you want, or if that is needed for your business. But yes, you can definitely use this framework to make your model smaller and yet performant.
I guess that's the end of the questions. So thank you, Surabhi, for joining us today. I hope your health gets better.
Yeah, sure. Thank you so much. Thank you.